随时叫我。
这个不要，这个 power 得 on 啊。
在这里。
对啊，你得 power on。
对，在这里。
那个刚才 power 没 on。
好的。
你后 OK。这现在可以。OK。
你是会扫对着他那个麦克风就可以。
对，谢谢。No, it's there. Oh, already. This might take. Why this? Why this is not connected? Oh, 现在可以。 Hello, everybody. Welcome to the second part of the advanced robotics for the ME5402 and EE5106. And my name is Sam Ge. Okay, I'm in the ECE department. And of course, the EE5064, which did not take the first part. Okay, how many of 5064 here? Hello, can you raise your hand? I need to take your attendance. Okay, good. Jadon, you take attendance for the 5064, okay? And then later you report to Jadon you are here, okay? Because later the department asked me to pass your attendance to the department, okay? And so before we start on the advanced robotics and of course the dynamics control for robotic manipulators, maybe I would like to share with you a bit on my educational philosophy. So that's why to get you to get to know each other, okay? And then you see this is my department ECE. I'm very fond of my department, okay? And then this is my actual blog. You can check. And I started the social robotics laboratory in 2007 up to 2021. And I closed it. And then I was brought to the Material Robotics Lab, IFIM, Institute for Functional Intelligent Materials, okay? And here, the education, mediocre teacher tells, the good teacher explains, the superior teacher demonstrates, the great teacher inspires, and I'm also inspired, okay, to be a good teacher, okay? But I guess I don't know how, so I could do a combination, okay? So I would also tell you, also explain to you, and also demonstrate to you, and I also inspire you, okay? And so I did a bit of translation, and then if you know Chinese, you can check whether my translation is correct or not, okay? And if you say, Sam, you made a mistake, okay? Today I was teaching my research student. I said, teaching is easy than doing research. Because teaching, all I need is transfer the knowledge transfer. I transfer textbook knowledge, monograph knowledge to you, right? I hope you can get it. But research is different. Research, you need to get something out in air. Nobody knows. Only you and me know, and we get it done, okay? So then I have a very good student. They are learning students. I'm transferring them to research students, okay? Okay. Here, Darren challenged us. I'm so happy I have a big crowd here, okay? And then, you guys must be very daring, okay? So the truth that many people never understand until it's too late is that the more you try to avoid suffering, the more you suffer. Because smaller and more insignificant things begin to torture you in proportion to your fear of being hurt. And I do a lot of consultation to many people. I really found somehow in the path of their journey, because they are afraid of talk to the supervisor. They say, the supervisor is very fierce, I wait until the supervisor is very sunshine, I talk to him. And then when he got moody, you don't talk to him. Actually, maybe when he was moody, he was really got a problem. You can help him solve the problem, right? You become his buddy, right? But that's a joke, and also telling the truth. And so when you face problem, most of the time is our inner, not confident, okay? And then so if you have any unconfident, you can make it open. Any problem, talk to the supervisor. Any problem, talk to me, or talk to Jiadong, or talk to your friend, okay? On our course, okay? Okay, good. And then daring to be a pioneer, and then those Chinese, I think this is because that was that Japanese invasion China was really struggling. And all the Chinese don't know where the future is, okay? So he then, actually Lu Xun is, China become what it is today, started by two doctors, medicine doctors. The one is him, Lu Xun. He is a medical doctor by training, but he started writing novels, okay? Another doctor is Sun Yat-sen, and then he forget about medicine, and he said, I threw the Qing dynasty out, okay? And then subsequent people, then you know, okay? Actually, two doctors. Do we have any doctors here? You said, I don't want to do doctors. I want to do engineering. Do we have? I hope in the future I can have a doctor, okay? I really met a doctor. He do doctor and found doctor is so boring, and he went to do pure math. And he got a 2 PhD degree, okay? Anyway, so the young people now have more choices. So whenever you do in your research, in your study, in your life, there's a very much, for hope, there actually does not exist the so-called have or have not. So it's very much like the road on earth. There were none, in fact, initially. It becomes the road when there are many people walk through it. So I hope you can be the first one to walk through, okay? You would be the pioneer, okay? Okay, good. That's actually, because this is for master PhD, I believe many of you are doing PhD, right? How many of you doing PhD? Yeah? You see, this is very good for PhD, right? You know your journey, right? And how many people of you doing master, the rest of doing master, you want to do PhD, right? Yeah, and then you see, I recently, I did my bachelor in Beijing University of Aeronautics. And then I was supposed to design fighter aircraft, fly high, super speed, supersonic. And I went to Imperial College to do robotics, okay? And then when you are in the top school, people like NUS, places like NUS, Cambridge, or Imperial College, only those people not academically, intellectually challenging, then they join the company. Otherwise, they aim for Nobel Prize, okay? They stay in Cambridge or Imperial College, and NUS, we also have Nobel Prize winner now. Do you follow me? Kostya, okay? Novoselov is with us, okay? Okay, good. And then I like him very much. Lucia and Seneca, okay? He said, even while they teach, they learn. So in this classroom, don't think I teach you, okay? I'm actually learning, okay? Do you follow me? Then anybody can tell me what's the best way of learning? What's the best way of learning? Huh? Yes, bingo, you got it. Yeah, the best way of learning is to teach, okay? And then if any of you, when they felt your learning is really slowed down, you raise your hand or send email. You say, next class I teach for you. Okay? Is that okay? I say, 10 minutes. I give you the place, okay? Okay? We can do it. And if you see, or you form your own study group, you teach, okay? And I have a project, 2 or 3 people. You teach there, okay? You lead there. Do you follow me? Okay, good. My daughter, younger daughter, when she was in high school, she sponsored a boy every month, $38. I said, I can sponsor, but it cannot be my money, okay? Must be your money. Your scholarship is your money. And then I encouraged her to study good. And then so now she's still paying the money. I recently got a big check. And I found, where's the money? And she said, she will pay me back. Okay? Do you follow me? When you got a big dream, you can see some I can teach better than you. Do you follow me? Okay, good. And this one is from Asia. And he said, there's a teacher among 3 individual group. But he's BC 500, okay? He's BC 4 and AD already. So that means this Seneca is better than Confucius. It's okay. Do you follow me? Because he's 500 behind 500. I think any three teachers, they teach each other, right? But this guy basically any two. Do you follow me? And then what can you get a theory? In the 21st century, you don't need two. You only need one. What do? You teach yourself. Do you follow me? You teach yourself to be the champion in the world, okay? Like Elon Musk. Okay? Okay. So we are better than Seneca, better than Confucius. We are ourselves by design, okay? Okay. So integrity, professionalism, and love. You know, everybody talk about integrity. Nobody knows integrity except engineering. Why? Because in moral integrity, we can understand better from material integrity, structural integrity as engineers. Do you follow me? Those lawyers, they only talk. Okay? We engineers are the best. Okay? You don't believe me? You see the theories, the mathematics and physics, they are grand. I'm not saying they are not grand. They are grand, but engineers are grander. Okay? Because you think the theory don't work in practice. And then you need to modify, make everything, and then the aircraft, the airplane, all fly, okay? Do you follow me? You think you actually sit on a bomb, and then you comfortably drink Coke, and eat, and safely come to Singapore, okay? So all engineers, wonderful ideas, okay? Make it work. Do you follow me? Theoretically, it should not work. Do you follow me? There are so many errors any error can happen. But the engineer did the one that should never happen, you know? So the engineer good, right? Yes. Okay, good. Thank you. Then professionalism, the competence. So you are good. And then you must be practice and the education of professionals, okay? You help each other, okay? You are good. You practice, you are good. You also teach others. And then love. Love what you do what you love, and love people around us, okay, to grow and to contribute, okay. I really thank you all coming to my class, okay. I love you. Do you love me? Oh, thank you so much. How to learn. And this is really true in Asia, okay. We are shy, we are more conservative, okay. And then, so I share with all my Asian students, this is important. I'm not afraid of criticism. I'm also not afraid of support. If you need support, you ask, okay? And then I'm not afraid of praise. You say, you are beautiful. Yes, you say, thank you. You don't say, no. What do you want? You know, don't say, you say, thank you, okay? Do you follow me? Okay, you're handsome. You say, thank you, okay? Okay, good. And then, especially, I said, PhD are not a permanent head damage, okay? PhD are philosophical, doctor degree, you do wonderful research. Master, you are in Chinese called 老爷, okay? 老爷, so you are even better, okay? Okay, and then you are going to, you master the field, and then you move further to PhD, okay? Okay, for you to do that, you must understand this. Normal people have a normal comment, normal achievement, okay? And then abnormal people have abnormal thought, have abnormal achievement. If you have anything after the range of abnormality, okay, and then in the range of abnormality, not in the normal range, I say congratulations, okay? I don't see nothing wrong, okay? Okay, you should be very proud of yourself. And but make sure you are on this side, okay? not on the other side. But as you have been to come to NES, you have been eliminated from that side already, okay? You're all on the other side, okay? Okay, on the right side, okay? You're all on the right side, okay? Okay. And then with a huge, large heart, the world is huge, right? It's huge. With a bigger heart, the world is large. So I have a lady student, she's very young, she wanted to do PhD with me. She went to university 16, okay? And then she's very young. I said, you do PhD with me? I have one condition. Don't cry, okay? Any problem, you talk to me, no cry. Okay, she said, no problem, okay? That's a deal, then I can take her, okay? So we must have a big heart, okay? If you face any problem, we can all talk about it, okay? Okay. If you cannot solve it, I help you solve it, okay? Okay, good. And then the joint project, learning story interact. You basically, you gather the stuff, okay, as a team. Then you climb up the ladders, progress. Then you build up your big houses, okay? Okay, the project later you will enjoy, okay? And for the, except for my EE5064, you don't do the exam, but you need to do the project. For the other student, you need to do exam as well, okay? After the project, then you can enjoy your hard labor, okay? And I was telling, and this is tropical fruit. I did not put durian because some people don't like durian. But durian, if you like it, then you can put yourself in, okay? The PowerPoint I shared there, okay? Okay. So this is my philosophy. Is okay? Good, okay. Then I share with you my structures, course structures and sense of achievement. When I was teaching, all the students loves me, really. And somehow later, some students start to hate me, said, I cannot. But then I talked to my friends, and then I understand I need to give you a course structure. I was brought up in the period the professor can teach anyhow, anything in the sky, okay? They can examine exam. I would do the exam paper, okay? And then nowadays we better structured, okay? And then better structured. So that's why I put this effort with Jiazhong's help, okay? And then the course outline, we will do the review and of kinematics, and we will do the robotic dynamics, okay? Newton-Euler and Lagrange and the properties. We will do the position trajectory control. We also do the force control, okay? And then the assessment is 30%. Actually, I was pushing with my colleague 100% CA, okay? But then the faculty said, no, Sam, cannot push your luck too hard. So must have a minimum of 30. I'm sorry, but then this 30 only 1 hour, okay? Okay. I want to reduce your pressure. I know that young children, you guys have too much pressure. I really want to reduce your pressure from the final exam to, okay? And then the continuous assessment, 35% you already finished from Chichikan, right? Perfect Chikan, okay, you already done. Then you have my 35%, okay? I will give it to you in due course. So before exam, you already get 70 marks, You say, Sam, I don't want to go to exam, then you got the freedom already, right? But I do encourage you to go, okay? Because I want you to get all distinction, okay? All distinctions, okay? Do you follow me? 70, if I deduct 5 marks, you got 65, and you just barely pass, okay? Then your future employer, your PhD supervisor, what happened, right? But if you go the 30, you got a distinction, okay? Okay. And this one, all my students push them, you must do physical training, okay? Earlier I showed you the torturing. I know you guys life is so good, right? Ice creams, chocolates, and then sunshine life, cars. If I bring the people to ask walking team, mosquitoes, you don't like it. But then in my research lab, I made a rule. If no matter how smart you are, you don't do physical training, I close the door. Okay? So life is so good, I want you to live 100 years old. If you want, you can go 1,000 years old. Okay? Do you follow me? And I want you really have a even better life. Do you follow me? Okay, so that's why the place you stand never matter, only that you were there and still on your feet. Okay? So solid feet, strong body, and a roaring soul. And I have many students earlier, they work so hard. The eyes still work there. I said, no, go out to work. Okay? So therefore, I want you really to do the training, and then our teaching based on this. Okay? We start from simple, gradually higher. Okay? And then your physical training, you can start from simple, stand up, to stretch, and then later to running. Okay? Okay. The assignment for this module should be finished in a group of 3, except for the possible last 2 groups, okay? Because the modules, you try maximum 3, and Jiadong will work with you. I really thank Jiadong for help. And Jiadong, if you want, Jiadong is your senior, okay? And if you want, you can get a few juniors from a group, okay? Okay, good. And then, on the 3D printing trained the manufacturing industry, I was learning the machining. Now, 3D printing, many jobs can be done by the manufacturing 3D print. Deep learning trained the machine learning. If you do the classical machine learning, so difficult. Deep learning, even high school, get structure, I can get the job done. Do you follow me? Okay. And actually, technology has been developed to such state that I can drive my car very good. I don't need to know how the car is designed, okay? And then even the phone at one stage, those art students get a tool was paid better than the engineers doing that, okay? So technology become modular, portable, and transferable. And we should keep on learning, study, and research for the most updated, okay? Okay, and then now WeChat comes, right? WeChat would get rid of many professors. Okay? Okay, chapter 1, I will learn how understand the structure of general structure robots, understand the formation of a DH matrix, and understand the direct kinematic and inverse kinematics, and then capability, be able to solve direct and inverse kinematic for typical robots, can think, do information search, and solve more complex demands such as with rotations, okay? These are skills you should have. And chapter 2, and you understand the concept of dynamics of robots, understand principle application of 2 dynamic formulations, and understand the property of dynamic models, and then capabilities, be able to apply dynamic models to specific robots, be able to solve dynamic equation proficiently. This is a nice English. Actually, as long as you can solve, I'm okay, okay? You don't need to compete with machines, okay? Okay. 3, understand the purpose of the control system, understand the modeling and control of single-joint robots, understand the decoupling, linearizing, control multi-joint system, and then capability, be able to model robot system, be able to apply control law partitioning, be able to design partition control for simple system, okay? And 4, understand reason, concept force control, understand method of one degree and undegree force control, and the concept of hybrid position force control, understand the method of impedance and the constrained motion control. Be able to design one degree and undegree force control. This is a bit more complicated, so my requirements are less. I want to give you 1, okay? And then the mini project is a group project on application of kinematics, dynamics control of few typical robots to be released. And then last year, we have this. And this is really not a real-life robot, okay, scenario, not a textbook scenario, right? Because after you take my course, you want to make a big bucks in the industry, right? Or you want to do further research. So this was the task, introduction literature review, like you do research papers. And robot design application, kinematic computing, and kinematic dynamics computing, control design simulation, and then you conclude, okay? So this two type of task. And then actually you can also design your own project of interest. That's why I say a few typical robots. And then you can design your own project of interest because you form a group of 3. You say, I don't like this cleaning robot. I also don't like, I have my own dream robots, okay? But you must involve kinematic dynamics and control, okay? And then you can discuss with your group, discuss with us. So that's why with this, you can say, I do give you inspiration, right? I give you inspiration. You take it or not, it's up to you, okay? I give you inspiration already, okay? Okay. And the course is we make it such that fun and interesting, kinematic dynamics. I try to make it really an interesting project, practical and useful. Job perspective are excellent. Nowadays, even ChatGPT comes, you don't be afraid, okay? ChatGPT only replace the professors, the leaders, okay? Do you follow me? And then he will get the robotic thing, automation, all these things still useful. The doctors do surgery, do you follow me? ChatGPT only get the language thing there, but still you need people to do it, okay? Oh, good. Open the door for first study as a master or PhDs. So the sense of achievement, this is very important. With the basic knowledge prerequisite, we are to sharpen your technical skills of learning and problem solving, programming, and excellent information search. And actually, some time back, one student asked me the problem too simple. I said, oh, that's you can Google. And then at the end of the feedback, he said, I asked him a question. He asked me to Google. And then I felt nothing wrong. But then from the student perspective, he really needed my answer. But on the other hand, I also know Google or search become a very important skill a student must acquire, okay? And then so the year after in the class, I told anybody don't know how to Google, you can come to my office. I teach you how to Google. And there was really one student that came to my office, you know. He really don't know how to Google. And really help him. He also got a question. I have to solve it, okay? You don't laugh. That was an undergrad student. And I also have research fellows. Research fellows, he also don't know how to Google. And I teach him how to Google. When he left me, somebody asked him, what Sam taught you? Sam taught me how to Google, okay? And but anyway, it's a joke, but also fact. But those are minorities. And as an education, I want to help everybody pass, okay? Excel. So if the search, if you really open the door here, if you don't know how to Google, you can come to my office, okay? I show you how to Google. You know, when you do PhD, you see information search. Information search is very, very, very important, okay? Information search. If you found the correct information, your research smooth sails. If you found the wrong source information, only you dig, maybe if it's PhD 4 years, you spend 2 years in the wrong pool, and then it's really waste of time, okay? Okay, good. And then have an excellent big picture of the advanced robotics and robotic manipulators and some fundamentals of kinematic dynamics control, be able to solve related problems to a wonderful group robotic project, okay? So eventually this is the things that after you walk out of my classroom, you see Sam open the door for Google, and then the rest, the kinematic dynamics control and project, okay? Okay. Then we can move on. So far, so good? Okay. Okay. Yeah, and my name is Shuji. It's difficult to pronounce. Ge is English people don't know how to pronounce. They say, call me Miss G, okay? And actually Ge. And then German can do right, Ge, okay? So I said, to make our life easier, I said, call me Sam, okay? And if you guys, even younger, you can call me Uncle Sam, okay? And I'm here to help you. I'm not penalize you, okay? Do you follow me? Okay, I want you to have fun, enjoy your study journey in US, okay? And when I was, I help you, I really helped by many teachers. I sleep in the primary school teacher's home. I eat in my secondary teacher's home, and then so I helped by my teachers. That's why I'm so helpful to all my students, okay? Okay. And these are the references. I also put my book here. I got 2 books here, and then then I give it 2 quick before we march on. I think usually after the break you tend to forget everything, return to the first part of the lecture. Now after the break bring you back here, okay? So the review of kinematics. So this part review the formulation kinematic robotics, and the first general feature of robots. Second, the formulation of DH notations, and then 3, direct kinematic and inverse kinematics. And general features, this robot is being taught, right? And the robot can do many wonderful things now with vision, okay? So each rigid links are connected by either revolute or prismatic joints. Actually, you see our arm is a ball, okay? And our mechanical engineer design still not as good do this kind of design. So we still do this simple one, okay? And then so as technology moves, mature, and then we can do this kind of joint. And so this simple, right? You see this simple. Each link is connected by at most 2 others. Each joint link pair constitutes 1 dual freedom, and unjoint link pair constitutes undual freedom. After I explain to you, you start to see what we discuss is the most simple one, right? You see the ball one, we never discuss. And we just discuss simple one. But even the simple one is can do many complicated jobs, okay? So 2 basic joints, revolute, prismatic. And based on such 2 type joints, different kind of robots have been designed, development, and Heinz robots, and Boston Dynamics robot, okay? And Heinz robot is a friend of mine who work on it. And they have been widely applied in industrial automation for painting, welding, assembly, ironing, pelleting, and so on, okay? And now even we can have a robot there open the door for us, right? Okay, good. Link parameter of manipulators. A manipulator robot can be described kinematically by giving a value of 4 quantity of each link. You know, the link length, okay? Link length, A, and link twist, alpha, link offset, D, and joint angle, theta, okay? This theta. And the joint angle is the one you can control. Others are by design. Once design is fixed, okay? So this DH notations. And then Jikang should have told you there are 2 different. One is the crack, and the other one is the Cislano and Fulkinson's notations. And the only difference is actually this frame I is with link I. This actually frame I with joint I plus 1, okay? The link frame I with link I. That's the only difference. And then actually why the difference? This is actually linked with this, and you even though they have different assignments, but the end result for kinematic dynamic they should be the same. Okay. Okay. And then They extend AI to get xi, and then use the right-hand rule to get yi. And then frame I is considered firmly attached to link I, but a joint I plus 1, when AI for this correct, okay? And when AI equals 0, that means the link length is 0, then your xi is chosen normal to ji minus 1 minus ji. Then formulation of DH matrix, and then transformation matrix, Ti I minus 1. You know, this is fucking thing. This I expressed in frame I minus 1. Okay, this is crack. And as you can see, different from foods. Okay, this is they are different. Where S means sine and C means cosine. And why I actually ask you to take care of your body. I have one lady student. She's very, the skin is very fair. I asked him to walk under the sun. He said, no, I don't want to get dark. I said, you know, those people in Africa, when they get old, they don't have this bone problem. Only the sun gives you a lot of support to your vitamin D, and okay. So after I told her, and she immediately walked around. Okay, do you follow me? Health is important. Okay, and then why I mentioned this? Fu Qingxin is very famous, but he died at 50 something. Okay, 50 something, and his friend, his close friend, his students are my buddies now. George Lee and his friend Tamia Baoshao, they all mention him. He's so good. Okay, so take care of your body. Okay, okay. Yeah, his book, it was published after his death. Actually, this book. George Lee was his student because even after he died, the book was published. Okay, okay, good. Then after you've done the two different types, and then you found the property. Anything you do after you found it, you must get the property study. Okay, and then so this T you partition it into it. This is rotational matrix. This is the partitional matrix vector. This 0, 1 because this Fu Qingxin's book was actually control, sensing, vision, and intelligence. Because he died too early, that's why nowadays you talk about this is the father of AI. That's the grandparent of AI, you know, robotics. Actually, if he did not die, you see he opened the control, sensing, vision, intelligence. He's so early, 87. The vision, he did it, and then the intelligence, he did it. Okay, so why the matrix here was add this 0, 1 was for vision, to couple with vision. Okay, and then the computation, because the robot is going to, you see, going to play ping pong with you, so the vision was inside in the consideration already. Okay, good. And then the transformation matrix have a compound transformation. If the I plus 1 stuff expressed in I minus 1, and you have a Ti I minus 1, Ti plus I. So the I can cancel each other. You can find they have this compounding effect. And then the inverse, I don't know how many of you have done matrix inverse computation. How many of you have done using computer to do inverse computing? Or you use your hand to do inverse computing? You have done? So one element is easy, right? One element is very easy. Yeah. Two elements? Three elements? Yeah, four? You can do three, I think it can, but four is, I think you would forget it. Okay, you want to come to computers, okay? Then you use if you have done matrix inversion for 4, you know it's difficult, okay? And then so people studied the property, they found this nice property. You just do the inverse, do the transformation, this become easier compute, okay? So whenever you got something, you must study its property, okay? And then direct kinematic. Direct kinematic, basically, you know the theta, and you know where my hand can go, okay? And then when initially these people say robotic manipulator, any factors, nowadays the more I think about it, when I do my PhD, they say the robotic arm, robotic manipulators, the more I think about them nowadays, I think we can really say robotic hand, okay? Robotic arm now, robotic leg, do you follow me? When they first created, this is still, okay, gradually we can use, okay? So this is thetas, we can find the rotation and the position. So for each of these joints, you can find the corresponding DH notation. And then you compute them together, then you can find where your hand is, and also its orientation and its position. Do you follow me? You see, for you see, when you move my hand, you say, Sam, I know it's there. But our problem to make the machine understand. Do you follow me? Okay, good. When you do the control, you say the car move slow and steady. If you know how to drive, I think the instructor told you, right? Slow and steady. Human beings all know how to do it. But your job is to program the computer, know what is slow and steady, okay? Okay. So this is a direct kinematic, as you can see, it's very easy. As long as you know your neighbor's relationship, you compute them, you get your total chain, okay, of position and orientation. But the inverse is difficult. The inverse is difficult, okay? And then I give you the orientation, the position. I want you to find how I compute the theta 1, theta 2, and theta n. And then I would basically, these are the algebraic, take the critical directly, geometric, decompose spatial geometry to 2D, and numerical. So I will show you. This is the first degree freedom, single degree, okay? This is 1 degree freedom, theta 1, RP, XP, YP. For one link planning robot, that following relation hold. The position RP equals XP, YP, and equal L1 cosine theta, and then or you can write f of x. And then theta 1 arctan YP XP, right? So simple, right? I really hope life can be so simple. Okay, and I show you the second one. You know, intuitively should be very simple because you 1 degree add another degree, right? Okay, let's see. RP equals XP, YP equals L1 cosine theta 1, and also L2. You must have theta 1 plus theta 2 now. So similarly, you can get YP equals f of x. Okay? And then now you tackle the equation directly. You open this, you have 2 equations. And you square the 2 equations. Okay? You have this one, xp square, xp square, and yp square. Okay? And you add the 2 equations together. You have L1 cosine sine, and then the coupling term, right? You have xp equals rp. And then you have this equals 1, this also equals 1. And then because this one, cosine, and this, we have this relationship, sine theta 1, theta 2, you can open the bracket, you have this. And then this, you do, even though it's very clumsy, but then after you do manipulation, you found the whole lot equal to cosine theta 2. So therefore, this equation can become this. Okay? So good, right? Life is good, right? Okay? In the middle part, don't be afraid, okay? And there was one Tsinghua student. I met her in Beijing, and she came to me to NUS with somebody else. She wanted to see me and then to study some neural networks. And she was explaining to me her work. I explained to her, I said, your work is still too shallow, because she was doing PhD, okay? I said, you're too shallow. And then I explained the neural networks, and then you need to go up higher level. And then she was very bright. She said, Sam, the linear neural network, no matter how deep it is, still linear networks. So when you are studying, you read the complexity. Do you follow me? And then after you see this one, if I give you all questions like this, you thought life is so easy, right? But then when you do this, after all this manipulation, then you found the simple, you get your brain get more calm and steady. Do you follow me? So we still, after so troublesome, we still get a beautiful equation, right? And then you can find the theta 2 can be cosine theta 2 arc or arctan, okay? So depend on two expressions. Or you write the equation further, okay? You have both sides. This one times I1, L2 cosine theta 2. This for the second equation, L2 theta 2. Then adding the two equations together, and then I would not go, because again you have this one, you have cosine theta 1. Then this equation would further become this, okay? And I would not go one by one. You check yourself. I did the one for this one easy for you. In detail. This one you check yourself, okay? We got this one. And then you have 115 is here, right? Here you can use. And then 119, then you can find this equation. And in this equation, here, theta 2, you already obtained, okay? And then so this one you may take it as a known value. And then you can solve for cosine theta 1. You have this. And then theta 1 arc cos or arc tan. You see, you solve theta 1, theta 2. Compare with, you see this mechanically, I only add one more degree. But then the computation gets much more complicated. That's why I ask you matrix inversion. 1 element, 2 element, 3 element, okay? So when you add things, the computation become much more involved, okay? Now you know ChatGPT is really burning money, okay? And another one, why I ask you to do physical training. Your brain is a supercomputer. If you don't supply enough blood sugar to it, energy to it, it's also shut down, okay? Do you follow me? I have some students, I say save energy mode. When she want to do, she sit down, immediately go to the energy saving mode. I said, no, that means you need more exercises. Okay? Okay, good. Then I show you another one. This earlier was algebraic. This one geometric. Geometric, you have 1 degree freedom robot. This is rotation, right? And another one is like this, okay? Like this. So from the side view, you can see it's only this. And then from top view, you know the guy can turn. Okay, good. And then from top view, I have theta 1. So I have R1 equals xd squared plus yd squared. Okay? And then for the one side view, I would have this R2 here. R2 equals R1. R1 is here. Here is R1, okay? I'm changing my angle. Here is top view. This is my, okay, this is my R1. When third view, this is R1, okay? Okay. Then R2 equals this R1 square plus this square. This square equals ZD. I forgot how to write this. Maybe later I'll check. It's this portion. This portion equals ZD minus L1, L2. So this portion, okay? This R1, then R1 equals this. So I have this portion, okay? Okay, good. And then the theta 2 is this chap. Theta 3 is this chap. Okay? And you know the internal angle. Internal angle is cosine beta, this beta. I have L3, L4, and R2. This angle is given by R2 square plus R2 square plus L3 square minus L4, and divided by 2R2, L3. And also, this cosine, this theta 3 equals minus cosine pi minus theta 3. So external angle equals the minus the internal angle cosine, and then the minus this angle equals L3 plus L4 square minus R2. I have this. So therefore, basically, I found the beta, theta 3, and then I can find this theta 2, okay? And then theta 3 is basically, I can get it from here, okay? And then theta 2, I basically can get it from this beta theta 2, theta 3, I get it from here. Theta 2, you have Z, and theta 2, you have Z2 minus this, and then you have this R1. You have this portion, you plus this beta. Do you follow me? So you compose this portion plus the beta portion. Okay? Okay. Then, so I give you the method. I said the inverse kinematics, algebraic, I give you the planar, geometric, I give you the knock head one. And then the last one, if give you a very complicated manipulator or robotic arm, and then you cannot, these two methods cannot handle, and there's the last one method. Is called the numerical method, okay? And the iterative solution. And when the problem is too complicated, analytical solution will not be possible. Only computation solution is possible. Do you follow me? You know, give you a differential equation. If I ask you to solve the solution, it's only special case. Majority have to do computing. That's why computing has become so important now, okay? Shall we take a half an hour break for you to have a lunch, dinner? Sorry, dinner, half an hour. I see you at 7:30. Is this? Is this what Chikan also do the same, right? Chikan Perfect True. Also give you 30 minutes, right? Wow, you got such a good memory. You can use your external memory, write it down, okay? I give you 30 minutes, okay? Okay. And when 30 minutes, you know, food for your stomach, think why I needed the numerical Why you are so stuck? Get all everything analytical, okay? Oh, okay. I'll see you later. Hello, everybody. I wish you all had a good break. Right? Battery recharged, right? Your stomach. Okay. I had a fish burger. Okay. Okay. Now come back. Many PhD students, right? PhD are doctor, philosophical, okay? And then masters, you are in control, right? And then I want to ask you, the book you read more or the book you did not read more? You did not read more, all right? And then those mathematical equations, you can analytically solve compared with those you cannot analytically solve. How? Which one is bigger? You cannot solve actually much bigger, right? And so in life, you start with the invention of computers. Everything has to become digital. You cannot analytically solve, but computer don't care. Just no number crunching, okay? So give you the result. Do you follow me? So this is so easy. Consider two-link planar robot again. The differential, you have this function equals RP. Then you do each differentiation. You would have, here you have this function, right? You do differentiation, you do XP or YP. And then you would have XP, YP, and then you have this equation. And then so this is actually called as Jacobian, and theta dot equals RP. J is the Jacobian matrix. So from this geometric equation, you go to differential equation. You go one dimension higher. You heard of 降维打击, right? Okay, you go one dimension higher, then you have a bird's view. You watch downward. Okay, so this geometric equation cannot solve. So I go to the differentiation, and then there I watch one dimension downward, and then you found this theta dot can be a Jacobian inverse RP dot. Then, because I know where my theta initially is, then I do my integration. You get it. Do you follow me? So with this two, you don't care already, okay? You don't care all this. Too troublesome. I only give you 2-degree freedom, and it's so troublesome. And this is 3-degree freedom, so troublesome. But now with this, I don't care already. I just like the deep learning, that's 3D printing, like the ChatGPT, okay? You can do everything for you, okay? I think in the future, you don't need to talk to me anymore. You talk to GPT, okay? So on the advanced robotics, he will teach me the advanced robotics better than me. But now, this year I'm okay, okay? This year I'm still okay. But I don't know how, if somebody put the material on top of the internet and he go, he will become better than me, okay? Okay, good. So I still have, before I retire, I think I'm okay, okay? So this is a wonderful tool, right? And then, if you want to know more, and then I give you the books, okay? You try to read more. A journey from robot to digital human, okay? And then I think I leave it to you, okay? But as far as this course is concerned, so I give you a full picture already, okay? And algebra, geometric, numerical. Numerical is the future, okay? Okay, good. Okay. The learning outcome and understand the structure and general feature of robot, understand the formulation of DH, understand direct and inverse kinematics, okay? Be able to solve direct and inverse kinematics for type robots, can think, do information search, and solve for more complex methods. such as rotations, okay? And show you some of robots we developed. Okay? Oh, yeah. This is the robot we developed. This is Brigitte, a French guy. And then Pei Yuan is also here. You know this Sophia, right? And this robot can do localization, map building, and navigation, obstacle avoidance, climb upstairs. And this is the enhanced robot can do drawing. And this is actually cleaning, you all know, right? You also can come to household, give you a drink. And then this dog fight and autonomous driving, okay? So the robot is really coming in. And this is the first part. And then this is a review, okay? Now come to the second part. I see you got all nice pictures here, okay? I hand to her Suresh, you, right? You see, you got nice, you're the first one, because we have good communication, right? And then you are the first one. So then tomorrow, I hope, as I move, next week, somebody else move to the first one, okay? But you must do more talking, okay? You say, no, Sam, this I can redo it. I can change the order, right? Okay. If you one day you form your groups, you know each other, and then your in your PowerPoint in the project, you can do a PowerPoint presentation if you want. Okay, I'm willing to listen to you. Okay, you got nice pictures here. Okay, good. I don't have time to talk to each of you to see. Okay, but then you can send me emails to tell me your story. Okay, okay. Your dream. Tell me your dream. What you want. Okay? And I wish your dream come true, okay? Okay. So now, dynamics. I finished the review, okay, already. Then come to the dynamics. This part focus on theory and property of dynamic model of robots. And I have Newton-Euler formulation. This is, you say, Sam, I'm a master of it, don't worry, okay? Then Euler formulation, probably for mechanical engineering students, you are good at it, okay? But for electrical engineering students, probably you need to know more. And then property of dynamic models, the tutorials, and then we all the same, okay? And neural network modeling. And because neural network is so popular, also introduced here, okay? And also because I told you kinematic computation, if you cannot solve analytically, and then do computing, okay? Okay. And then we W square H, what, why, and how. What is robot dynamics? Okay, basically found the dynamic equation of motion of manipulator, which deals with the relationship between robot motion and the force torque applied externally. Okay? And then kinematics, Professor Chikan already shared with you. Kinematic deal with the relationship between the joint variable space and then position orientation of the end effect in the world space. As the robot becomes so popular now, I think this end effector can change. Robotic hand, okay? Because technically people don't want to confuse with human hand. But I believe robot is coming in as become a community. We would have a robotic beings already. Then robotic being would have a robotic hand, okay? So because earlier they don't want to confuse with human being, okay? But because robotic being is coming in, I guess we can allow to have a robotic hand, okay? Okay, dynamics is instantaneous, momentary, okay? And then so why do we want to study robot dynamics? Robot dynamic equations are used for first simulation digital twin of robotic dynamics. And then you can also see some add. Actually, now talk about metaverse, right? Metaverse. Fundamentally, it's computation, okay? Simulation. And it's a way of designing a prototype robot, testing control strategy without the expenses of working with the actual robot. It's much more economical. And as the material robotics, actually for the material science, we can manipulate atoms already. If we can manipulate atoms, anything you can after your dream, I can create something physically according to your dream come true, okay? Theoretically, okay? And then so we just push in that direction, okay? And then the controller design, most control design techniques are based on plant model. And moreover, model-based controller is superior to non-model-based control. If I know you, then our communication would be better, right? More fluent. The same for controller. If I control based on the model, then my control performance would be good. This can be theoretically proven, okay? Theoretically proven is by argument, mental thinking power, reasoning, okay? Just like earlier I was doing derivation with you. And as Confucius said, there was a teacher among any three, right? And then Seneca said, why they teach? They learn. So two people already. And I moved to the first century. Then I teach myself, right? It's also okay, right? You see, it's actually logical reasoning, okay? Okay. So this model-based control is superior to non-model-based control, can be theoretically proven, okay? Somebody did it. You don't need to do it anymore, okay? Okay. And how do we derive robot dynamics? Two basic methods, Newton-Euler equation or formulation, Lagrange-Euler formulation. And then you want your picture to be here, right? Yeah, you work hard, okay? Okay. You see Newton, Euler, and Lagrange, okay? And actually some of my students, they are quite famous already. And they are on some books already, okay? And so you work hard. One day I put your picture here. This is, okay? Okay? Okay. Don't laugh, okay? Don't laugh, okay? And then, I work in a nonlinear field. In a linear field is if your father is rich, you are rich. If your father is poor, you are poor. In a nonlinear world, no. Nonlinear world, your father can be very poor, but you could be super rich. Do you follow me? Okay. Okay, I work in the nonlinear field. Robotics is nonlinear, okay? Okay, now. Okay, I'm not joking. I'm telling you the absolute truth. Nothing but the truth, okay? Okay. All you need to do to make it, okay? Based on the Newton-Euler equation is the Newtonian mechanics. Forward, backward, recursive. And each link of robot is treated in turn. Lagrange equation is based on Lagrange mechanics. And closed form solution, the system taken as a whole. Okay? Lagrange is kind of like a deep learning. This is the whole lot. It works. Why it works? It works. According to Lagrange. Okay? I will show you later. Okay? The Newton mechanism, you can see why it works. Okay? And then this method 1 and 2 are providing different insights. Any other formulation in the future obtained fundamentally from these two formulations. Okay? And a brief comparison between the two. Recursive form, less structured, no general property, difficult for controller design. Lagrange-Euler closed form, well-structured, general property exists, suitable for controller design. This was when the two first move out. Okay? But as people move, then they found these two are actually equivalent. But you need to do more conversion, okay? Some simplification. And so Lagrange formulation can be made as efficient as Newton-Euler formulation. So on the equivalent. And for control the stability and system closed form are Lagrange preferred. Okay, I give you this. Any other method are based on the about two fundamentals. Okay. And Newton-Euler formulation. Bless you. And in deriving the equation motion, Newton mechanics are also used by considering each link individually, which state fundamentally, you see, every action has equal and opposite reaction. This action and reaction. You know, your boat, you push the boat away. The rate of change of the linear momentum equal to the force applied to the body. Okay? And here, F equals dmv over dt. The rate of change of angular momentum equal to the torque applied, N equals d over dt I omega. Okay? The standard. This is if M is changing, okay, and then I is changing, if M is constant, you can move the M out. And in this formula, I can take care of M and I are changing, okay? Okay, mapping review, okay? And then, you know, in the translation, if this cart is moving, the guy is also walking, this observer, and actually the C equals A plus B, okay? Both plus this car and then the walking. So note that the prime, okay, is moving frame or rotating frame later, okay? This is the prime. And then the rotation. The rotation. And sorry. No, this is the prime is moving. This is fixed, okay? This is this should be P, add the P. 加动, this should be add the P. Yeah. Okay. This should be fixed, okay? Yeah. Okay. So this is the moving one. This is the reference frame. Okay, the total XP equals must be the moving frame with respect to the base plus this guy in the prime. Okay, and then the rotation. This is actually the position expressed in the prime. So this have a position, you have a rotation plus the prime. So this is the position in the XY frame, and this is the position in the rotational frame. They have a relationship. This R equals IJK and expressed in the IJK prime. Okay, so writing the unit vector of frame in terms of frame XYJ and stack them as the column. Okay. And then for translation plus, okay, and then here is the position with respect to frame O, and then you have basically equals C. Then you equals A plus B prime. Then B prime equals the rotation. This matrix, this frame actually rotated plus the B, okay? Or you can write as a rotation from the frame 1 to 0 and with respect to the position in the frame 1. Do you follow me? It's a bit involved, but it's clear, okay? And the linear velocity, then you have this position, you have the position A, basically the position with respect to frame A equals basically the base origin expressed in A plus the position in frame B with time the rotation of B expressed in A. It's quite clear, right? It's a little bit involved if you read the subscript and superscript. It's quite clear, okay? And then base 0 expression A. And then velocity is the same as higher dimension. So we do differentiation. Then I do differentiation, I got V, the velocity expression A. So I have this velocity base. And because this fixed, okay, this is still translation. RBA is constant, so I have this. Then you see, Sam, if RBA is moving, what is it? If RBA moving, more involved, okay? I will show you later. I show you the simple one first. Okay. If rotational velocity, you see, if frame A, frame B, the frame B is rotating with respect to A along this axis omega, I use the frame to express. And then I use this topping to show you that's indeed the case. Have you played topping? Oh, good. You see this guy? You see the topping, if you stop rotating, the topping would fall off, right? But if you keep rotating, the topping is very steady, okay? Now, if you want to become healthy, you need to keep it rotating, okay? Okay. Keep rotating. Okay. And then I show you the rotation around the axis in the inertial frame. You see this guy rotate. And then velocity equals omega cross r. You know this rule, right? Omega across, so the velocity in that. And the acceleration equals omega cross velocity. So this, you see the acceleration this. So the acceleration was omega cross r. You see, when you have rotation, it's more complicated, right? But good, you got this nice picture here. And then you can also do the computing here. You see how you get it, okay? So this PA, I move a little bit delta P. So delta P would be equals PA sine theta, give me here, and then omega, and then time delta T. So the velocity equal limit delta P over delta T, and then would be equal this, okay? And limit, and then so this is, and I show you, then you can have this, you know, A cross B equals AB sine alpha, this standard. If you use cross, IJK, okay? You follow me? Do you still remember this? Do you still remember? When you have P omega cross PA, actually AB cross, you write like this, or you write AB cross actually equals A norm for A norm B sine alpha. Okay? So this is sine theta. Do you follow me? You could. Somebody says yes. If you not sure, you talk to those people, knock their head, okay? Okay? And if you still cannot solve, you talk to me or Google, okay? Okay. So at least this is one. Okay, I can show you, okay? And this one we all agree, right? Okay. Now, I come to this is my favorite page. For constant PB with respect to frame B, and then PA equals RPB. PB is constant, right? So your derivation of PB equals 0. And then if I do derivative, I have PA dot equals VA dot, all clear, right? Then equals R dot cross PB. And then this gives me omega cross PB. Do you follow me? This is basically say this velocity equals omega R, okay? And then this velocity equals omega P, okay? Okay? Okay. For changing PB, I add complexity beta by beta, okay? For changing PB, Then PB would be dot would be VB. Then you have PA equals I do PB dot. I have this component. Then RA, then I would have omega RBA PB. Okay? Okay, good. You see, that's why I give you this page. So important. When you do R, you must have omega cross. Okay? Then simultaneous linear and rotational velocity. So you have two components. This linear. Then the VA would be equals this guy derivative. Then this guy is derivative. Then I have this component. Okay? Okay, good. Then acceleration of rigid body. Then acceleration, I do this guy from here. I do further derivative. Okay? I do further derivative VA equals V dot. And here, this would be VB dot. And then when I do this guy, I would have a omega cross V. Okay? And then omega cross this, and then I do further. Okay? So this VA dot and omega BA cross this. And then others would be here omega dot. You have omega dot. Then you have further this R. You would have omega cross. Then you do further, you do the PB. And then PB would become BB. Then you have this. So that's why here you have two. Okay? Got it? You basically do differentiation one element after another element. This guy, because I do derivative of this R cross omega cross VA. And then another two is virtually I do derivative of PB. PB become VB. Okay? VB, RB, VB, and then omega. So I have this two. And if PB is constant, then VB dot equals 0. This guy would become this guy eliminate. This guy eliminate. I have this. Okay? That okay? Because all the symbol is so, unless you have a graphic memory, you can try to remember it. Okay? One shot, another shot, another shot. But really, if you keep watching it, keep looking, you would remember like one page. Okay? But for the time being, as long as you follow my derivation, you say correct. Then you say this slide is okay. Okay? You can do real later. Okay? Okay. Acceleration, angular acceleration. Angular for 3 frames, A, B, C, rotating angular speed, omega BA, omega CB. Then you have omega CA equals omega BA plus rotational BA omega CB, because omega CB you express in the A frame. Okay? So when you do differentiating, you would find this derivative equal this derivative plus this derivative. And when you do the rotational matrix derivative, things become omega cross itself. This is omega cross itself. You always remember this, okay? Velocity equals omega cross itself. And then omega cross itself, okay? Okay. And then Newton's equation. Newton's equation, you have mvc dot equals F. VC acceleration of center of mass. F is acting on the center of mass, the force, okay? And when I change it, and then sometime, but you put the cursor there, it's right turn, the thing disappeared, okay? Euler's equation, you have I omega dot plus omega cross I omega equals N, okay? N is the torque acting on the body. I is the inertial tensor in the frame with respect to the origin located center of mass. Omega velocity, omega dot is angular acceleration. And then you have this di omega equal dt. This is due to the change in omega. This is due to rotation of the vector. Okay? So then for robotics, you basically have a forward, backward algorithm. Okay, and then from the base, your base is fixed. Then 1 degree move, another degree move, and then another degree move, like Michael Jackson, right? The cloud walking, and he knows where the hand moves, right? Okay, and when they backward, you must know where your hand moves, then until go to see which force to move which joint, how much force needed, okay? Going forward is a position. Moving backward is the torque or force needed, okay? Okay, good. It all makes sense. You think about it, all makes sense, okay? Okay. And then outward iteration from 0 to 5. You number from 0, the base, and then to 5. So if the joint I plus 1 is a revolute, okay, and then rotational, okay, so you see, you add something extra. That means this degree freedom, you see, is rotating, okay, for omega. Do you follow me? The rotating added in, okay? If the prismatic, you don't contribute to rotating. You see, the rotating remains the same, okay? You don't contributing. Only you rotate, only rotating adds to the rotating, okay? And then for acceleration, you do further derivative. Here, you do further derivative, or this dot, and this double dot, plus this, when you do R dot, you would have this Ri omega and cross the theta I dot J, okay, for rotational. And then acceleration, again, remain the same, okay? And then for computation, you have theta I plus 1 dot J, okay? Basically, JII basically give you 0, 0, 1 to notate the vector. And this did you compute, then become this. So that's why when you're doing programming, you need to understand the notations, assignment, frames. You really need to be very careful. And then, so to express it, this actually equals 0, 0, 0, 1, okay, to express your idea. Actually, in your brain, you know it like this, can be very simple, okay? And then linear acceleration of the origin of each frame, the linear acceleration. Linear acceleration, you have Vi dot, the first frame, and then omega I pi dot plus this guy, omega I cross omega I and cross pi, okay? If this is rotational. And then for the velocity, if it's prismatic, then the velocity you see here, for angular motion, the rotation you add in. Here, for linear acceleration, you see the rotation don't add much, okay? And then the 1 degree change, you don't change here. But then for prismatic, indeed change. You have these two tails added in, okay? You have these two tails. This change in the z direction, this due to the coupling. And the linear acceleration of the center of mass, okay? And then you have C. This is actually the origin of each frame. This corresponds to the frame. Now this is away from the frame and then go to the center of frame. Then you have omega cross the position. This you need to see equation 1, 1. You see, you get it from here, okay? There's offset, and you can get it from here. From there, you get this equation, okay? From here. And then the linear acceleration of the center. And then from this, you can find the force needed. And you can also find the torque needed. Do you follow me? This is the forward, okay? And then this is a forward from the base. You go from the base 0 to 1, and 1 to 2, until you go to 5. Okay? You see, from I to I plus 1. Do you follow me? From I to I plus 1. Okay? And then from 0 to 1, 1 to 2, you go moving. As I said, Michael Jackson moving the hand. Okay? And then you get to see this. You imagine this, because of this 5. 5, you add 1, becomes 6, right? For 6 degree freedom, final one is 6. After your 6, how, suppose I hold a mass. Then my last joint, I would know how much for that acceleration moment of inertia, the angular velocity, I know how much force or torque needed. And I can compute backward. Okay? So this is the force needed for moving the mass center. This is torque needed for the movement inertia. And then from 6 to 1, I do inward computing. Inward computing here, I got all my force, torque to move the mass center of mass, right? Then I need to project it onto the joint, onto the axis. Okay? And then this is the force. This is the torque. And then on the corresponding axis, once on the corresponding axis, then for mechanical engineering students, you will know if I have a force, if I have something needed on here, but because of my support can also provide, I only need to project onto this axis how I rotate. Okay? So this is actually the force and torque, the total. And then here I project onto the corresponding motor. Okay? And then this one, then I project back to my feet. Then I know each one I turn. And I can achieve that motion. Is it good? I'm sorry it's tedious. But if you use the 1 degree freedom robot, would be very easy, right? But if you use 2 degree freedom, would be more common. This I give you a generic one, okay? And then I give you an example. I hope it would make you feel relaxed. But I also doubt it because the symbols is a bit complicated, okay? So I still use the 2 degree freedom robot. We are very familiar with, okay? This 2 degree freedom. And then derived the dynamic model for the planetary 2-link manipulator. Suppose that the robot is under the influence of gravitational acceleration. I mean the robot is in this space, okay? In this space, the gravity can pull me down, okay? And then assume that the mass of each link is lumped at the end of the link. Assume the mass is here. M1 here, M2 here. And then the length L1, L2, okay? Theta 1, theta 2. Now assign coordinate frame. This is the inertial frame, x0, y0. The first frame, x1, y1. And the second frame, x2, y2. And then the any factor, x3, y3. Do you follow me? I'm going through as much as I have been talked in the review, the DH coordinate, okay? I'm assigning it to it. Then assign according to the DH coordinate. So here, then the center of mass of each link is represented in the coordinate system as this. The center of mass, here I use the center of mass. Yeah, the center C. C stands for center, okay? The C, PC, okay? Here, PC1 is 0, 0, L1, okay? And then PC2 is 0, 0, X2. And this is there at X, XL, XL. Do you follow me? So this will be assigned, okay? The J is a bullet coming towards me, okay? So the J is 0. And then each coordinate system represented under each appropriate coordinate system is the P10 is 0, 0. P21 is L1, 0, 0. Is it okay? You follow me? I did not lose you, right? You're still with me, right? Okay. So I assign the coordinate x0, y0, x1, y1, frame 0, or I use a frame 0, frame 1, frame 2, frame 3. Okay? Frame 3 for the end effector. And then I have PC1 because the mass center is at M1 here, and PC2, and the mass center is here, okay? Okay. And then since the robot is in gravitational environment, the base is subject to gravitational acceleration. So in the Y, I have a G. Okay? In the Y direction, I have a G, velocity G. Okay? Velocity dot, the acceleration dot. And the mass of each link is lumped at the end of the link. The base cannot be moved, so there's no force on any effector. So I see 1, I see 0, I assume 0. Initially, the base frame 0 is also 0, and any effector force, because the guy don't push anything, the force and torque also equal 0. Okay? Okay, good. And then the rotational matrix between base, link 1, link 2, you have 1 to 0, and then 0 to 1, 2 to 1, 1 to 2. It's okay, right? All clear, right? Okay, good. And then, I'm sorry, a bit messy, right? But then, even though a bit messy, it's all understood. Omega 0 equals 0, omega 0 dot, and omega 1, okay, corresponding to theta 1 dot, omega 1 dot corresponds to theta 1 double dot, and by equation 2.14 to 2.111, and here from here to 11. To here, okay? Here is 11. Then you can get V1 dot, okay? And then you can find you basically substitute all those stuff we have defined, okay? This is 1, 1, 0, 1, 1, 1, 0, and 0, 0 cancel, and then have 0, 0 cancel, have 1, 1, okay? The same here, and then you have this, and then you substitute R0, 1, R0, 1 is here. And then you substitute here, then you get to compute, you get this. And VC1, the VC you have here. VC here, okay? VC here, and then you substitute, correspondingly, you can substitute, compute, eventually got this, okay? And here, C cosine theta S sin theta N11 equals 0, 0, okay? And then accordingly, you have the force 1, 1 equal this, okay? And then after link 2, then in a similar manner, you can go to the link 2 for omega dot, and V2, okay? Here you do 1, 2 to 1, 4, okay? 12214 here, and you get it, okay? And then, sorry. Yeah, here is the outward, and then you have the the VC, the center of mass dot, and you can find the force needed, and also the torque, and then you do the inward. Inward, once you got this, you start to computing the force and torque for corresponding the total mass, and then total moment of inertia, and then you found the torque. The torque you need to project onto from here, okay? Project onto here, and then you for link 1 from equation 2.818 to 2.10, 8 to 2.10, you follow this, and then you can find the 1 torque. Then you can find the corresponding torque for the. As you can see, it's really complicated, okay? But tedious, but it's very clear actually. Then you can find tau 1, tau 2. So this is the dynamic equation using Newton-Euler formulation. I and my students spend time did it one by one. It's very boring for me to repeat one by one, okay? You check yourself, okay? Gradually, if you have any question, you talk to us, okay? And then what I want to say, for this 2-link degree freedom robot, and this Newton-Euler formulation, you would, after so complicated derivation, you would get the dynamic equation here. This dynamic equation, I can rewrite into this form, DCG form. And then DCG form, I told you earlier, I said this actually two, they are equivalent. They are equivalent, so Euler can be made as efficient as Newton-Euler. This Newton-Euler, this form, and this Lagrange-Euler form. Eventually, after you done the derivation, this is your Newton-Euler formulation, and you write in metric form. This actually, next week, I will show you Lagrange-Euler formulation. Lagrange-Euler formulation, you obtain this equation beautifully. Okay? Very beautifully. This one is still beautiful, but you need to do the knitting really one by one, okay? And then the other one is much more beautiful, and and then I show you the form here. So this learning outcome, understand the concept of dynamics of robots, and I share with you understand the difference between Newton-Euler formulation and the Lagrange-Euler formulation. Also give you a brief conversion. Understand the forward-backward algorithm of Newton-Euler formulation, and then be able to apply forward-backward algorithm to calculate Newton-Euler equation. Okay, for simple one, I show you 2-degree freedom. You see, it's so complicated already, and the translation is easy. Okay, if you have two translations, but once rotation involves so complicated. Okay, I give you for simple cases. Okay, I think I stop over here. Okay, this is the first time I see you. I try to be easy. Try to be easy with you. Okay. But I made it, even though so complicated, okay? The final one I made it say it's so clear, okay? Follow me? Even though the middle is messy, but finally I show you it's clear, okay? Okay. Okay, then any question? Jiadong, you want to say something? Jiadong is my TA, okay? He volunteered to support me. And last year he also helped me, and so really thank him, okay? And I also promised him for research, if he got any problem, he can ask for my help, okay? Okay, the same offer to you. If you need my help, just talk to me, okay? Okay then.
show you simple and gradually move more complicated. Later, my translation of this later I will assemble the just now or I think that last year. I think we will use it. Maybe I take it on my phone. Thank you. 说的朋友啊，因为我们